As the energy marketplace evolves, the challenge for nuclear utilities is to deliver nuclear generation that enhances performance, decreases costs, and provides the highest levels of safety. This led to AECL's new Candu design, the ACR 1000. This evolutionary design is based on nuclear power technologies that are in operation around the world. Capitalizing on leading and enhanced technologies with innovative construction techniques, the ACR 1000 can be built quickly and at low cost. Meeting recognized safety and performance standards, the ACR 1000 is more economical to operate than existing plants. Like other Candu reactors, the ACR 1000 is unique with its ability to refuel on power. This feature, when combined with Candu's renowned fuel efficiency, provides significant advantages that other types of reactors cannot. Defective fuel, for example, can be detected and removed without shutting down the reactor. The plant can also run for extended periods without the need for a planned outage for fueling. In fact, a Candu plant leads the world record of 894 days of continuous operation, resulting in operators minimizing their financial impact associated with fuel-related outages. The ACR 1000 on-power fueling process is highly automated and is based on decades of experience accumulated from around the world since 1963, resulting in the fueling process that has proven to be highly reliable and safe. This video presentation provides an overview of the prime features of the ACR 1000 on-power fueling system while illustrating a typical fueling sequence. The fueling for the ACR 1000 starts with the arrival of new fuel bundles in the new fuel loading areas located next to the containment building. Here, the bundles are removed from their packaging and thoroughly inspected. The field operator tracks each bundle by its unique serial number. Inspected fuel bundles are manually loaded into the new fuel transfer mechanism trough. A motorized loading ram loads pairs of fuel bundles into the new fuel magazine. The magazine is then closed and sealed, allowing the fuel to be transferred through the containment wall to one of the two fueling machines. Fueling operations, starting with the new fuel loading, are automated and controlled from the main control room by a qualified fuel handling operator. Inside the containment, a fueling machine is aligned and clamped onto the new fuel port. The fueling machine snout plug is removed and stored. With the containment boundary maintained, the transfer ram pushes up to 16 new fuel bundles, one pair at a time, into the fueling machine magazine. Once the fuel is loaded, the containment isolation valves are closed. The fueling machine snout plug is replaced and the machine is filled with water. The fueling machine then unclamps from the new fuel port. The two fueling machines automatically move to the first selected fuel channel. When the alignment is complete, the machines clamp on to the end fittings of the selected fuel channel. A leak check is performed and the process of opening the channel begins. Each fueling machine removes the snout plug, followed by the closure plug. The upstream fueling machine removes the fuel support plug and inserts two new fuel bundles into the channel flow. The other fueling machine at the downstream end of the channel unlocks the fuel support plug. The fueling machine ram is then retracted and the fuel string follows. This allows the last pair of spent fuel bundles to be separated from the end of the fuel string and stored in the magazine. This spent fuel is continuously cooled with the fueling machine closed-loop water system. The magazine rotates and the next pair of spent fuel bundles is removed from the channel. This process continues until the specified number of bundles are removed. When complete, the downstream ram pushes the remaining fuel string and the fuel support plug back into the fuel channel. The upstream fueling machine adds additional pairs of bundles to complete the 12-bundle fuel string. It then reinstalls the fuel support plug in the upstream end fitting. After both fueling machines replace the channel closures and snout plugs, each machine then depressurizes the snout plug cavity and confirms that the channel closure is leak tight. Successful leak checks allow the machines to unclamp and back away from the fuel channel end fittings. The two fueling machines are repositioned to the next pre-selected fuel channel in the refueling sequence. Typically, two channels are refueled during each trip to the reactor, a process that takes 3.5 hours to complete. Once the selected channels are refueled, the spent fuel is then transferred to storage. The downstream fueling machine clamps onto the spent fuel port. The snout plug is then removed, opening the fueling machine to the transfer port. The spent fuel port containment valves are then opened, allowing the ram to push the spent fuel bundles, one pair at a time, into the spent fuel port. Water circulated through the discharge tube pushes the spent fuel into the spent fuel transfer mechanism located in the reception bay. The containment valves are then closed. The spent fuel bundles are transferred into stainless steel storage baskets. Each storage basket holds 36 bundles. Once filled, the baskets are moved underwater to the main storage bay. Typically, the spent fuel is stored here for up to 6 years, after which the fuel is dried and the sealed baskets are transferred to on-site dry storage. On-power fueling has been employed safely and successfully in Candu plants that have been designed and built by AECL around the world for over 40 years. Fueling the ACR 1000 is an automated and reliable process that provides the owner with unique capabilities and flexibility for operating the plant.